Science doesn't hold grudges. It just waits quietly for you to ignore it. Number 1. In 1753, physicist Georg Wilhelm Richmann decided a thunderstorm was the perfect laboratory assistant. Inspired by Benjamin Franklin's electrical research, Richmann had equipment installed at his home in St. Petersburg to measure atmospheric electricity. There was one catastrophic problem. His apparatus was insulated instead of being safely grounded. During a storm, Richmann stood near the equipment while an engraver watched. A powerful electrical discharge jumped from the apparatus toward Richmann and killed him almost instantly. The observer survived, although the blast knocked him down and damaged the room. The cruel irony is that Richmann wasn't chasing superstition. He was investigating something real, important, and scientifically revolutionary. His death actually helped demonstrate exactly why lightning conductors needed a continuous path into the ground. Electricity had delivered the harshest peer review imaginable. Excellent question, terrible experimental setup. Number 2. Alexander Bogdanov was a Russian physician, philosopher, and genuine pioneer of blood transfusion research who became fascinated by an extraordinary possibility. Could exchanging blood rejuvenate the human body? During the 1920s, he underwent repeated transfusions and believed they improved things like his eyesight and general health. Then came his fatal experiment in 1928. Bogdanov exchanged blood with a young student who had suffered from malaria and tuberculosis. Both men developed severe reactions afterward, but the younger student recovered while Bogdanov's condition deteriorated. He died roughly 2 weeks later after severe kidney failure associated with the transfusion reaction. Blood typing, compatibility, and transfusion medicine were still developing, making procedures far more dangerous than modern patients might imagine. Bogdanov spent years exploring whether another person's blood might extend vitality. Instead, his final experiment demonstrated something much less romantic. Biology does not care how confident the researcher holding the needle happens to be. Number 3. In 1945, Los Alamos physicist Harry Daghlian was performing a criticality experiment with a plutonium core, carefully surrounding it with heavy tungsten carbide bricks that reflected neutrons back toward the material. Instruments warned him that adding another brick could make the assembly supercritical, so he began pulling it away. Then the brick slipped. It fell directly onto the assembly, producing a sudden critical reaction. Daghlian immediately tried to knock it away, then began removing surrounding bricks by hand to stop the reaction, increasing his exposure while ending the emergency. He received a massive radiation dose and died 25 days later from acute radiation poisoning. Afterward, Los Alamos changed safety procedures, including rules against conducting such experiments alone and moves toward remote-controlled equipment. The terrifying part wasn't that Daghlian misunderstood nuclear physics. He understood exactly what was happening. One dropped object simply turned an equation into a countdown. Number 4. Physicist Louis Slotin knew exactly how dangerous a plutonium core could become, which makes what happened in 1946 even more chilling. At Los Alamos, he demonstrated a criticality experiment using 2 beryllium hemispheres positioned around a plutonium core. Instead of relying on safer spacers, Slotin held the upper hemisphere apart with the blade of a screwdriver. The screwdriver slipped. The hemisphere dropped, briefly surrounding the core and sending it supercritical. Witnesses reported a blue flash and a wave of heat. Slotin immediately knocked the hemisphere away, ending the reaction, but he had already received a devastating radiation dose. He reportedly calculated his own exposure and understood what was coming. 9 days later, he died from acute radiation syndrome. The core became infamous as the Demon Core. Science had provided the warning, a screwdriver had provided the loophole, and physics closed it permanently. Number 5. In 1967, test pilot Michael J. Adams climbed into the rocket-powered X-15, an aircraft that looked less like an airplane than something Wile E. Coyote might order from a government catalog. Adams reached an altitude above 260,000 feet, high enough to qualify him posthumously for astronaut wings. During descent, however, the X-15 entered an unexpected spin at hypersonic speed. Adams recovered from the spin, but the aircraft then began a violent oscillation as it plunged into denser atmosphere. The aerodynamic forces became enormous. Traveling several times the speed of sound, the X-15 broke apart over California's Mojave Desert, killing Adams. Investigators later identified several contributing factors, including distraction, instrumentation issues, and control system behavior. His death helped drive changes in cockpit displays and flight control procedures. At ordinary speeds, confusion gives you time. At hypersonic speed, confusion gets a stopwatch, and starts counting backward. Number 6. Mount St. Helens had been broadcasting warnings for weeks before its catastrophic eruption in 1980. Earthquakes shook the region, steam explosions blasted the summit, and a gigantic bulge grew on the volcano's northern side. Authorities created restricted zones, but lodge owner Harry Truman became famous for refusing to leave his home near Spirit Lake. Truman was 83, outspoken, deeply attached to the mountain, and convinced he understood its moods after decades living nearby. Reporters turned him into a stubborn folk hero. Then, on May 18th, the volcano answered. A massive earthquake triggered the collapse of the mountain's north flank, followed by an enormous lateral blast racing outward at devastating speed. Truman disappeared beneath volcanic debris along with his lodge, and his body was never recovered. His confidence made great television. Geology remained unimpressed. A volcano does not negotiate with experience, personality, property rights, or stubbornness. When a mountain starts physically changing shape, staying home stops being independence and becomes an appointment with geology. Number 7. David Johnston understood Mount St. Helens better than almost anyone watching it, and that knowledge placed him directly in its path. The 30-year-old volcanologist worked for the United States Geological Survey and strongly supported keeping the dangerous area around the volcano closed. On May 18, 1980, Johnston was monitoring the mountain from an observation post roughly 6 miles north of the summit. At 8:32 that morning, an earthquake triggered the enormous landslide scientists feared. The volcano's northern flank collapsed, releasing pressure and producing a devastating lateral blast aimed almost directly toward Johnston's position. His final radio transmission began. "Vancouver, Vancouver, this is it." Seconds later, the blast overwhelmed the observation site. Johnston's body was never found. His death wasn't caused by denying science. He was there because he understood the danger and was measuring it. Sometimes proving what nature can do requires standing frighteningly close when nature finally decides to demonstrate. Number 8. The Space Shuttle Challenger disaster remains one of history's most devastating examples of engineering warnings colliding with schedule pressure. Before the launch in January 1986, engineers at contractor Morton Thiokol raised serious concerns about rubber O-ring seals in unusually cold temperatures. The seals were crucial because they helped contain hot gases inside the solid rocket boosters. The morning was bitterly cold by Florida standards, yet Challenger launched with 7 astronauts aboard. 73 seconds later, the shuttle broke apart. Investigators determined that an O-ring in the right booster failed to seal properly, allowing hot gas to escape and ultimately destroy the vehicle. All 7 crew members died. The Rogers Commission later examined the technical failure and the decision-making culture surrounding the launch. Challenger wasn't defeated by some mysterious force nobody could predict. The warning signs existed beforehand. The tragedy was that physics had already submitted its paperwork, and management effectively stamped it, "Launch anyway." Number 9. In 1986, Lake Nyos in Cameroon looked peaceful enough to belong on a postcard. Beneath the surface, however, volcanic carbon dioxide had been dissolving into the deep water under enormous pressure. On August 21st, something disturbed that unstable arrangement. The lake suddenly released a gigantic cloud of carbon dioxide in what scientists call a limnic eruption. Because the gas was denser than air, it hugged the ground and flowed silently into nearby valleys and villages. People and animals collapsed without understanding what was happening. Roughly 1,700 people died, along with thousands of livestock. There was no lava, no cinematic fireball, and almost no warning. Scientists later installed pipes designed to release the accumulated gas gradually. Lake Nyos demonstrated something terrifyingly simple. A natural disaster doesn't need to roar. Sometimes physics arrives quietly, removes the oxygen, and leaves an entire landscape looking almost untouched. Number 10. In 1954, Japanese fishing vessel Daigo Fukuryu Maru was operating in the Pacific when the United States detonated Castle Bravo, its most powerful nuclear test. The crew was outside the officially announced danger zone, which should have made them safe. Unfortunately, the explosion produced a yield far greater than scientists had expected, and radioactive fallout traveled much farther than predicted. Hours later, white ash began falling onto the boat like strange snow. Crew members handled it, brushed it from the deck, and continued working because they had no idea they were being contaminated. Soon they developed nausea, burns, and symptoms of radiation sickness. Radio operator Eikichi Kuboyama died months later after severe complications. The incident became an international scandal and transformed public awareness of radioactive fallout. The The crew hadn't challenged nuclear physics. They trusted somebody else's calculation of it. Castle Bravo proved that when the math is catastrophically wrong, the safety line drawn on a map becomes decoration. Number 11. On June 30, 1971, Soviet cosmonauts Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov completed a historic mission aboard the Salyut 1 space station. Their Soyuz 11 spacecraft appeared to return normally, descending under parachute and landing exactly as planned. Recovery crews opened the capsule expecting 3 exhausted heroes. Instead, they found all 3 men dead. During preparations for re-entry, a ventilation valve had opened unexpectedly while the spacecraft was still in space. Cabin pressure escaped rapidly, leaving the crew desperately trying to locate the leak as their oxygen disappeared. They were not wearing pressure suits because the cramped Soyuz configuration could not accommodate 3 suited cosmonauts. Investigators reconstructed the disaster and redesigned later spacecraft procedures and equipment. The horrifying lesson arrived inside an apparently perfect landing. The parachute worked. The capsule survived. The navigation succeeded. But space had found one tiny opening, and vacuum needed no second invitation to come inside. Number 12. In 1983, commercial diver Byford Dolphin suffered one of the most infamous pressure accidents ever recorded. The diving rig used a pressurized chamber system that allowed saturation divers to live under pressures similar to those deep underwater. During a routine transfer operation, a chamber connection was opened while parts of the system were still at radically different pressures. The result was explosive decompression. Pressure inside plunged from roughly 9 atmospheres to normal atmospheric pressure almost instantly. 4 divers died, along with 1 crew member, while another person was seriously injured. The physical effects were catastrophic because gases dissolved in body tissues suddenly expanded faster than biology could possibly compensate. Later investigations focused heavily on equipment design, procedures, and safeguards intended to prevent such a pressure differential from being released accidentally. There was no monster, storm, or mechanical explosion in the conventional sense, just one invisible force equalizing itself. Pressure had only one rule: balance the difference, regardless of who was standing nearby. Number 13. On August 21, 1986, the village of Lower Nyos had already shown how invisible gas could kill. But another industrial disaster made the same principle terrifyingly urban. In 1984, a pesticide plant in Bhopal, India, released a massive cloud containing methyl isocyanate and other toxic substances after water entered a storage tank and triggered a dangerous reaction. Safety systems were inadequate or unavailable as the pressure and temperature climbed. Shortly after midnight, poisonous gas spread across densely populated neighborhoods where thousands were sleeping. Official immediate death estimates reached into the thousands, while later deaths and long-term health consequences pushed the human toll far higher. Investigations exposed failures involving maintenance, training, equipment, emergency planning, and plant safety. Chemistry had not behaved unpredictably. The chemicals reacted according to their properties. What failed was the machinery and decision-making surrounding them. Bhopal became the nightmare version of an instruction label nobody gets to ignore twice. Number 14. In 1981, 18-year-old David Kerwin visited Yellowstone with friends and stopped near Celestine Pool, one of the park's beautiful hot springs. When a friend's dog escaped the vehicle, jumped into the pool, and began struggling, Kerwin rushed toward the water. Witnesses warned him not to enter. He reportedly understood that the spring was dangerously hot, but jumped in anyway to rescue the animal. The water was around 200 degrees Fahrenheit. Kerwin managed to climb back out, but suffered catastrophic burns across nearly his entire body. Despite intensive treatment, he died the following morning. The dog did not survive either. Yellowstone's thermal pools can look like oversized natural hot tubs, but they are powered by geothermal systems capable of boiling water near the surface. Kerwin's instinct was human and immediate. Unfortunately, compassion could not negotiate with thermodynamics, and Yellowstone offered no emergency setting marked cool. Number 15. In 1978, a group of West German engineers working at Spain's Los Alfaques campground discovered how violently liquefied gas can expand when containment fails. A tanker truck carrying roughly 23 tons of liquefied propylene was traveling past the crowded seaside campground when its tank ruptured. Investigators concluded the tanker had been dangerously overloaded, leaving insufficient room for the liquid to expand as temperatures increased. Escaping propylene rapidly vaporized, spread through the campground, and ignited. The resulting fireball devastated an area packed with vacationers, killing more than 200 people and injuring many others. The disaster led to tighter rules governing hazardous material transportation and tanker loading. Nothing supernatural happened inside that truck. Liquid warmed, pressure increased, containment failed, and flammable vapor found ignition. It was basic physical chemistry operating on a horrifying scale. Somewhere beneath every maximum fill line is an invisible sentence. The empty space is there for a reason. Number 16. In 1947, the French cargo ship Grand Camp sat in Texas City carrying ammonium nitrate fertilizer when smoke was discovered below deck. Rather than immediately flooding the hold, the captain reportedly avoided using water because he feared damaging the cargo. Steam was used in an attempt to control the fire while spectators gathered along the waterfront to watch the strange orange smoke. Then, chemistry ended the sightseeing. The Grand Camp exploded with tremendous force, destroying nearby buildings, igniting industrial facilities, and triggering additional fires and explosions. At least hundreds of people were killed in what became one of America's deadliest industrial disasters. The blast was powerful enough to shatter windows miles away and produce a wave felt across the harbor. Ammonium nitrate looked like ordinary fertilizer until heat transformed the situation completely. Saving cargo suddenly became irrelevant. The invoice survived only in theory, while Texas City received a brutal demonstration of why burning oxidizers demand extraordinary respect. Number 17. In 1982, British Airways Flight 9 flew directly into something its radar could not clearly reveal: volcanic ash from Indonesia's Mount Galunggung. At cruising altitude, strange blue electrical glows appeared around the aircraft before all 4 engines failed. Captain Eric Moody famously informed passengers that the airplane had a small problem, possibly history's calmest description of becoming a glider over the Indian Ocean. The crew descended thousands of feet while repeatedly attempting engine restarts. Eventually, as the aircraft exited the densest ash cloud, the engines restarted and the Boeing 747 landed safely. Nobody died, which is precisely why the incident became scientifically important. Volcanic ash can melt inside jet engines, coat internal components, and choke combustion while remaining difficult for conventional weather radar to detect. Aviation procedures changed dramatically afterward. 4 engines had effectively voted against continuing the flight, and unlike most committees, their unanimous decision received immediate attention. Number 18. In 1979, Air New Zealand Flight 901 carried sightseers toward Antarctica, promising passengers one of the most spectacular views on Earth. Before departure, however, navigation coordinates had been changed without the flight crew fully appreciating how significantly the programmed route differed from earlier briefings. The aircraft descended for sightseeing while approaching Mount Erebus. A phenomenon called sector whiteout made the enormous snow-covered volcano visually blend into the cloudy background, destroying normal depth perception. The crew believed they were looking across open terrain until the ground proximity warning suddenly sounded. Seconds later, the DC-10 struck Mount Erebus, killing all 257 people aboard. Investigations became controversial, but the disaster permanently demonstrated how navigation, communication, and human vision can fail together. Antarctica did not hide the mountain. Light simply erased its edges. When your eyes say empty horizon and the instruments disagree, geography gets the final vote every single time. Number 19. In 1975, the Banqiao Dam in China faced rainfall on a scale its designers had never expected to confront. Typhoon Nina stalled over the region and dumped extraordinary amounts of water into reservoirs across Henan province. Banqiao had been designed for an extreme flood, but the storm exceeded assumptions while communications, spillway capacity, and emergency responses struggled under worsening conditions. The dam eventually failed, releasing an enormous wall of water downstream and contributing to cascading failures at other dams. Tens of thousands died directly in the flooding, while disease and famine afterward drove estimates of the total death toll far higher. Entire communities were overwhelmed before many residents could escape. The tragedy became one of history's deadliest structural disasters. Engineers built dams by calculating what nature might reasonably produce. Nina delivered something beyond those expectations. Water does not recognize design confidence, political promises, or impressive concrete. Give it enough height, volume, and gravity, and eventually the blueprint becomes merely a suggestion. Number 20. In 1985, scientists working near Colombia's Nevado del Ruiz volcano had already identified a nightmare scenario. An eruption could melt summit ice, creating fast-moving volcanic mudflows called lahars capable of reaching populated valleys below. Hazard maps existed, warnings circulated, and the volcano erupted on November 13th. Hot material melted part of the ice cap, sending enormous rivers of mud, rock, and debris racing downhill. The town of Armero sat directly in their path. Many residents received inadequate warning, and evacuation came too late. Within hours, much of the town was buried. More than 20,000 people died there, with additional deaths elsewhere. The science behind the danger was not mysterious. The deadly pathway had effectively been mapped beforehand. Nevado del Ruiz became a devastating lesson in the difference between knowing a disaster is possible and acting before possibility becomes momentum. The volcano supplied the evidence. Bureaucracy supplied the delay. Number 21. In 1952, London discovered what happens when ordinary pollution meets perfect weather for disaster. Cold conditions encouraged residents to burn large amounts of coal, while a temperature inversion trapped smoke and industrial pollution close to the ground. Beginning in December, a thick yellow-black smog swallowed the city. Visibility became so poor that transportation slowed, pedestrians struggled to navigate, and indoor spaces filled with polluted air. The truly deadly part appeared in hospital and mortality records. Thousands died during and immediately after the event, especially from respiratory and cardiovascular problems, with later estimates placing the overall toll much higher. The disaster helped drive Britain towards stronger clean air legislation. Nothing exotic had attacked London. There was no mysterious poison or experimental weapon. It was familiar smoke accumulating under atmospheric conditions that refused to let it escape. The city had essentially put a lid over its own exhaust, and chemistry turned everyday pollution into a mass casualty event. Number 22. In 1984, British coal miner Michael Hickson and hundreds of others were aboard the Soviet cruise ship Mikhail Lermontov when it struck rocks near New Zealand and began taking on water. But maritime history offers a far deadlier lesson in the same unforgiving principle: the Herald of Free Enterprise disaster in 1987. The ferry departed Zeebrugge with its bow doors still open. As the vessel accelerated, seawater poured onto the open vehicle deck. That broad deck allowed water to spread rapidly, destroying stability with terrifying speed. The ferry rolled onto its side shortly after leaving harbor, killing nearly 200 people. Investigators uncovered failures involving procedures, communication, and corporate safety culture. The physics itself was brutally elementary. Place enough freely moving water high inside a ship and stability disappears. The ferry did not need an iceberg or hurricane. One open doorway was enough to let the ocean rewrite the entire operating manual. Number 23. In 1991, Mount Pinatubo in the Philippines began waking after centuries of quiet, and this time scientists managed to predict something enormous. Volcanologists from the Philippine Institute of Volcanology and Seismology, working with the United States Geological Survey, monitored earthquakes, gas emissions, and swelling around the volcano. Their warnings triggered large evacuations before the major eruption in June. Then came the complication nobody needed. Typhoon Yunya passed nearby during the eruption, soaking volcanic ash with rain. Wet ash became dramatically heavier, collapsing roofs across the region and causing many of the eruption's fatalities. Hundreds died despite the successful evacuation of many thousands from the most dangerous zones. Pinatubo proved two scientific lessons simultaneously. Prediction can save extraordinary numbers of lives, but surviving the obvious threat does not cancel the secondary ones. Volcano plus typhoon is nature's version of finishing the exam and discovering there is another page stapled to the back. Number 24. In 1959, 9 experienced hikers entered Russia's northern Ural Mountains and never returned alive. The Dyatlov Pass incident later attracted decades of theories involving secret weapons, mysterious attackers, and practically everything except aliens filing paperwork. Modern scientific investigations have offered a far less supernatural possibility. Evidence indicates the group abruptly cut their way out of their tent and fled into extreme cold, with some victims dying from hypothermia and others suffering severe traumatic injuries. Research published decades later demonstrated that a delayed slab avalanche was physically plausible under the unusual terrain, snow accumulation, and winds at the campsite, although debate about details continues. What makes the case so unsettling is that wilderness does not require a conspiracy to become lethal. Darkness, wind, unstable snow, and temperatures far below freezing can turn a confusing emergency into an irreversible one remarkably quickly. Sometimes the monster in the mountains is simply mechanics operating after midnight. Number 25. On January 28, 1986, Challenger showed what ignored engineering concerns could cost. 17 years earlier, Apollo 1 delivered an equally brutal warning before ever leaving the launch pad. In January 1967, astronauts Gus Grissom, Ed White, and Roger Chaffee entered their command module for a routine ground test. The cabin contained a high-pressure, pure oxygen atmosphere, while numerous combustible materials and vulnerable wiring surrounded the crew. A fire suddenly erupted inside. In pure oxygen, flames spread with extraordinary speed and intensity. The inward opening hatch could not be opened quickly against rising cabin pressure, trapping all 3 astronauts. They died within minutes. NASA's investigation led to major spacecraft redesigns, including a safer atmosphere during ground operations, reduced flammable materials, improved wiring, and a rapidly opening hatch. Apollo 1 never flew, yet it changed every Apollo mission afterward. The spacecraft was built to survive space. Its fatal weakness was sitting motionless on Earth. Number 26. In 1940, Washington State opened the original Tacoma Narrows Bridge, an elegant suspension bridge so slender that workers had nicknamed it Galloping Gertie because the roadway visibly moved in strong winds. Engineers knew it flexed, but the movement was initially treated as manageable. Then, on November 7th, steady winds transformed the bridge's motion into something far more violent. The deck began twisting dramatically as aerodynamic forces fed energy into the structure instead of damping it. Traffic stopped, and the last person on the bridge escaped, but a dog named Tubby remained trapped inside an abandoned car. Attempts to rescue him failed. Eventually, enormous sections of roadway tore apart and plunged into Puget Sound, taking Tubby with them. No human died, but the collapse permanently changed bridge engineering and aerodynamic testing. Tacoma Narrows demonstrated that wind is not merely something a bridge stands against. Under the wrong conditions, the structure can accidentally become wind's dance partner, and wind always leads. Number 27. On July 17, 1981, the Hyatt Regency Hotel in Kansas City was packed for a popular tea dance when 2 suspended walkways suddenly collapsed onto the crowded atrium below. The disaster began with what looked like a small engineering change. The original design called for continuous support rods running through both elevated walkways. During fabrication, that arrangement was changed to separate rods, effectively doubling the load on critical connections. The revised detail was approved without adequate calculation. During the dance, connections failed, and tons of steel, concrete, and glass crashed onto people beneath. 114 people were killed and more than 200 were injured. Investigations exposed catastrophic failures in design review and professional responsibility, transforming engineering standards nationwide. There was no earthquake and no freak weather. Gravity simply received a connection that could not carry the promised load. The change looked minor on paper. Physics apparently neglected to read the memo, calling it minor. Number 28. On July 19, 1989, United Airlines Flight 232 was cruising toward Chicago when an engine at the tail catastrophically failed. Fragments severed all 3 hydraulic systems, leaving the pilots without normal control of the DC-10. Captain Al Haynes and his crew discovered they could influence direction only by adjusting thrust between the 2 surviving engines. For more than 40 minutes, they essentially steered a giant passenger jet using engine power alone while preparing for an emergency landing at Sioux City, Iowa. The aircraft reached the runway but crashed during touchdown, broke apart, and caught fire. 111 people died, yet 184 survived, an outcome investigators considered remarkable given the near-total loss of flight controls. The accident transformed training and understanding of hydraulic system vulnerabilities. Sometimes science proves its point through failure. Here, it also proved something else. Even when the airplane becomes nearly uncontrollable, disciplined improvisation can still steal lives back from the mathematics. Number 29. In 1974, a chemical plant near Flixborough, England, temporarily removed a cracked reactor from a system producing caprolactam. To keep production running, workers installed a temporary bypass pipe connecting 2 reactors. The improvised arrangement lacked the engineering support and analysis expected for equipment handling highly pressurized cyclohexane. On June 1st, the temporary system failed. A huge quantity of hot, pressurized liquid escaped, rapidly vaporized, and formed a flammable cloud. When that cloud found an ignition source, the resulting explosion devastated the plant, killing 28 workers and injuring dozens more. Buildings were damaged far beyond the site. The disaster became a landmark case in process safety engineering, emphasizing rigorous management of temporary modifications. That last word matters. Temporary sounds harmless, like folding chairs at Thanksgiving. Chemistry hears something different. A molecule does not know whether a pipe is permanent, provisional, or installed until Friday. It only knows temperature, pressure, containment, and whether somebody underestimated all three. Number 30. In 1998, workers at the Esso natural gas plant in Longford, Australia, faced a process upset that caused extremely cold liquid to enter equipment normally operating at much higher temperatures. One heat exchanger became dangerously chilled. When warmer material was later reintroduced, the metal experienced severe thermal stress. The exchanger fractured, releasing hydrocarbons that ignited into an enormous fire. 2 workers were killed and several others injured, while gas supplies across Victoria were disrupted for weeks. Investigators later focused not simply on equipment failure, but on inadequate training, poor understanding of the plant's hazards, and weaknesses in operational knowledge. The accident became a textbook reminder that industrial systems cannot be safely operated by memorizing buttons without understanding what happens behind them. Metal expands, metal contracts. Temperature differences create stress whether the shift supervisor appreciates them or not. The control room may have manuals, procedures, and blinking screens, but metallurgy has been enforcing its own operating instructions for considerably longer. Number 31. On July 23, 1983, Air Canada Flight 143 ran out of fuel at 41,000 feet. The Boeing 767 was supposed to carry enough fuel for the trip from Montreal toward Edmonton, but Canada was transitioning to the metric system, and a conversion error helped produce a disastrously incorrect fuel load. Somewhere between pounds, kilograms, and fuel density calculations, the airplane departed with far less fuel than required. Both engines eventually stopped. The aircraft became a massive silent glider. Captain Robert Pearson happened to have gliding experience and directed the powerless jet toward a former Air Force base at Gimli, Manitoba, now being used for motorsports. He landed there without fatalities, despite people occupying the runway area. The aircraft became famous as the Gimli Glider. Nobody died, making this the rare warning delivered without a funeral. Science still made its point spectacularly. Units are not decorative accessories attached to numbers. Forget the conversion, and your jetliner becomes an extremely expensive sailplane. Number 32. On April 26, 1986, operators at Chernobyl's reactor number 4 attempted a safety test intended to determine whether spinning turbines could briefly power emergency systems after electricity was lost. The experiment unfolded under dangerous conditions. Reactor power dropped unexpectedly, operators withdrew control rods beyond safe operating margins, and crucial protection systems were disabled or bypassed as they tried to continue. The RBMK reactor also possessed serious design flaws, including characteristics that could increase reactivity under precisely the wrong circumstances. During the test, power surged catastrophically. Explosions destroyed the reactor, and the exposed core burned, releasing radioactive material across large areas of Europe. 2 workers died that night, while dozens of firefighters and plant personnel later died from acute radiation sickness. Longer-term consequences remain extensively studied. Chernobyl was supposed to test how the reactor responded to an emergency. Instead, it became the emergency. Nuclear physics did exactly what the conditions allowed. The operators discovered that safety systems become surprisingly ineffective after you deliberately remove them. Number 33. On January 28, 1986, 7 astronauts climbed aboard Challenger while engineers were worried about something deceptively ordinary: cold rubber. The solid rocket boosters used O-rings intended to seal joints and prevent extremely hot gases from escaping. Engineers at Morton Thiokol had evidence that unusually low temperatures could reduce the seal's ability to respond quickly, and some argued against launching in the freezing conditions forecast at Kennedy Space Center. After discussions between engineers and managers, the recommendation changed and NASA proceeded. Challenger lifted off before millions watching live, including American schoolchildren following teacher Krista McAuliffe's mission. 73 seconds later, hot gas escaping a booster joint contributed to structural breakup of the vehicle. All 7 crew members died. The Rogers Commission later exposed both the technical cause and deep communication failures surrounding the decision. Challenger remains horrifying because the crucial warning did not arrive afterward. Engineers raised it before launch. Physics was already objecting. Management simply overruled the wrong department.